In this video, we're going to start looking at proofs and what makes a proof valid and all the elements that we need to have in a proof for it to work and to be a valid argument. So your objective is that you can state the different ways that you can write a proof. There's more than one way to do it, and it's kind of up to you which way you want to write it, whatever one you're more comfortable with, and that you can state what needs to be included and why to make a valid argument. So what is a proof? A proof is just a logical step-by-step argument to prove why something is true. You do proofs in your life without actually realizing it. Think of the last time you tried to convince your parents you wanted to do something. They're not just going to always take your word for it. You need to back it up. So that kind of goes into why do you need to learn this. Yes, there's geometry proofs and students tend to not like them very much. But it's important that you are able to start at point A and get to your conclusion and figure out why I can do this and this and this. There's many careers out there that you are going to have to make a valid argument to your future employee. For example, if you're looking into like law enforcement, the police have to have a valid argument of why somebody is arrested. They just can't arrest when they want. They need to have proof to charge somebody. Or if you're in the business world or you're a lawyer, same kind of thing. Your boss isn't just going to take your word for it when you have this great idea. You need proof to back it up. Or a doctor. If a doctor says you need surgery, he needs proof, or he needs to be able to make an argument of why something is true. So in every part of the proof, there are certain things that you're going to need, and this relates more to a geometric proof, but you kind of use this in your everyday life too. There is always a given. This is your start. This is your starting situation. So taking it out of the geometric concept, and let's go back to the doctor's example, you could say something like, my leg hurts. That's a given. A lot of times when you come to the doctor's office, you have your symptoms. And from there, they can, you'll be given a diagram. A diagram is just something to help you look at it. Sometimes you may not be given the diagram, but drawing one is helpful. And from there, the diagram can help you make conclusions. And then from there, you need to have statements and reasons. So for example, your leg hurts. Your diagram could be something like an x-ray. Your statements, well, the x-ray shows that it is broken. Why is it broken? Well, you can see the crack in there, so that would be a statement and a reason. And there could be swelling. Well, why do things swell? Well, that because from history or from medical records that they're swelling when there's something wrong. And then you can get to your conclusion. So in a geometric, you have a given. I'm going to give you a situation. You know this is true. You can assume this is true. And then from there, you are given a diagram. And in that diagram, you can help you make conclusions. And then from there, you're going to make a series of statements. Now the statements, there can be just a couple of them. There might only be two, and it could be to a whole bunch. When you really get deep into mathematics, when you get into the college level or into the master doctorate level, I have myself written proofs that have taken 2 pages. Obviously, we're not going to do that. We're just starting to get the idea of what a proof is. But to make your point clear, you need to back up of everything. And the way you back it up is with your reasons. Now, valid reasons are postulates that we have dealt with, definitions, if you know the definition of something. For example, if you know the definition of parallel lines, you know parallel lines do not intersect. So you can use that definition to prove your point. You can say these 2 lines do not intersect. Well, why? Because definition of parallel lines, they are parallel. There are theorems that we have gone over that you can use, properties of certain objects, or even the given info. You can use your given as a reason. If I give you a statement that angle A is congruent to angle B, well, the reason why you know that is the given. So you do this kind of going back and forth. That's why I have the arrows back and forth until finally you are ready to say, I have given you everything you need to go to your proof. And your proof is kind of your conclusion. At the start of every proof, I'm going to have a given and I'm going to have a proof. The prove will be your last statement you make. And the reason would be from one of these up here. So let's take a look at what this will look like. Well, actually, let's look at what different types of proofs you have. The first type of proof, it's the one you're probably going to see most often in work. It's a 2-column proof. And a 2-column proof is just kind of helps you line up step by step of how to get to your proof. So generally, you have your given statement here. And I should say, at the start of every proof, there's a given, which will say something, and then there's a proof, which will say something, and then there'll be some fancy diagram over here where it will help you, which will relate to what's here. So you have a given statement, which the statement that is written here generally is the first thing you write down. Sometimes it could be written later, but usually your first statements are given, or the given may have more than one thing, so you write one here and write one here. It doesn't matter. But if you see the given written, well, then your reason is your given. And then you're just going to do a series of steps that you would think, I know this, because of this, I know this, because of that, I know that, because of that, I know that. And then you have your reasons over here, your theorems, your postulates, until finally, the last thing you write down is the statement that is written here. That statement is your last statement here, and then it will be again some reason. And usually when you're looking at your reasons, you want to look at the previous one. And I'll kind of explain that when you actually do a proof. So that's what a 2-column one, where it's just kind of step by step by step by step. And we like to label, this is step 1, step 2, or statement 3, statement 4, statement 5, until you have finished your proof. A paragraph proof is just writing it out. To me, I like the 2-column and I like the paragraph proof because I can just write it out and say, I know this, and then I know this, and then I know this, and I know that. And again, when you start it off, you have your given statement, and then you're just going to write all your statements until you get to the end, and then your last statement is what you're trying to prove, and why do you know that. And that's very important. A lot of geometry is knowing why something is true. You have to defend yourself. We're going to make you into good lawyers. Or even if you don't have lawyers, a lot of times you're going to have to defend yourself. Even as a teacher, I'm constantly asked, why is something true? Or why do I need to do something, and I need to back it up with evidence. And the last one, most common proof, is a flow proof. Or a flow proof is kind of just like in a diagram. You start with your given, and you can draw arrows, and you have a statement, and then you put the reason in there. Because of that statement, you know this statement, which give you your reason, and then you know that. So it's kind of like a 2-column, but you just keep going until you're all done, and then your proof, and then your reason why you know that proof. And again, these are just 3 examples of a way to write proof. You could probably think of other ways to write a proof. The most important thing is that your argument is valid, and that you have your statements and your reason to go from step to step to step to step. So just kind of review. Usually the number one thing students like, this is usually the number one thing students like about geometry. I'm not afraid to tell you that for some of you, you are absolutely going to hate this. You are going to be screaming my name and cursing it out because you think proofs are super, super hard. But it's an important thing to learn to make a valid argument. Again, no matter what career you're going to be, is a valid argument, and you need to learn to lay out your argument step by step by step by step. And since geometry is made up of theorems and stuff, we need to know why things are true to prove your point. Again, use your logic. Why do I know this? Really ask yourself, why do you know this? Why do I know this statement is true? Again, it's going to be tough. It will get easier. I promise you, especially when we get into triangles and parallel lines, when things start to make more sense. This unit is going to be a little tougher because you're starting to see them, but I'm not going to be expecting you to be masters of the proofs by the end of the unit. When we get into proofs in unit 5 or 6, then I'm going to expect you to do a great job with your proofs, and you're going to be able to start from end. But that time you're in master mode, you're going to think it's really easy. Trust me, I've had many students who freak out when I first introduce the proofs, but when we actually get into proofs about triangles and stuff, they're like, well, this isn't so hard, and they actually enjoy it. It becomes more like a puzzle to them than just kind of a headache. Just a reminder to do a reflection to get credit for watching this video.